Good evening, this is Mr. Wintermelon, and in this lesson, we will learn about limiting factors. We have learned about two factors which affect the rate of enzyme activities. First, it is temperature, and second, it is pH. Today, we are going to discuss about two more factors. But first, what is limiting factors? So a limiting factor is a factor that prevents or limits the rate of reaction from becoming faster. And we have learned two of the factors. First, it is temperature. The higher the temperature until the optimum temperature, the faster the rate of reaction. As well as pH, the optimum pH will result in the fastest rate of enzyme activity. Today, we are going to learn about substrate concentration and enzyme concentration. So, what are these two factors? So, what I have down here are three markers as well as the marker cap. I also have my hand down here, as all you can see. So, the analogy here is the marker as well as the cap is the substrate, while my hand is the enzyme. And the function of my hand or the enzyme is to catalyze the binding of the cap to the marker. So I'm going to give myself 10 seconds to see the rate of reaction or how fast my hand can cap the marker. So 10 seconds begins now. Now, I actually finished capping all the three markers before the time runs out. So my speed regardless is 3 markers per 10 seconds. So right now, if I increase the number of enzyme or the number of hand, will it increase the rate of reaction? No. If I have 2 hands, the rate of reaction will still be 3 marker per second because there is simply not enough substrate or the marker. So right now, my hands or the enzyme is not a limiting factor. The limiting factor or the factor preventing the rate of reaction from going higher is the number of marker. So how do I increase the rate of reaction? Now, I have increased the concentration of substrate or the number of markers to 6. So let's see whether the rate of reaction will increase with the increase in concentration of substrate. So let me press. So as you can see, the rate of reaction increased from 3 substrate per 10 seconds to now 6 substrate per 10 seconds. If I increase the concentration of the enzyme, the rate of reaction will still be 6 marker per second. So my enzyme concentration is still not the limiting factor. Do you think I can increase the number of reactants or the reaction that happens? How do I increase the number of product that will be produced? What I have done right here is I have increased the substrate concentration even further by adding more markers. So now let us take a look at whether the enzyme activities can be increased. I will start the timing now. Okay, so I'm left with one marker that is uncapped. That means I managed to increase the rate of enzyme activities from capping 3 markers all the way until 8 marker right here. My question is, if I increase the number of substrate even further, let's say I add 3 more to 12, what will be the rate of enzyme activity? Will the enzyme activity increase if I only have one enzyme to cap the 12 marker? So logically, the rate of reaction will not increase with the increased concentration because I am only using one hand, or I only have one enzyme. So right now, increasing substrate concentration will not increase the rate of reaction. Therefore, the substrate concentration is no longer a limiting factor. So if the substrate concentration is not a limiting factor, how do you think I can increase the rate of reaction if I increase the number of substrate? I can add in more enzyme so that I can increase the rate of enzyme activities by maybe twice the speed or 3 times if I have 3 hands. So the limit of me or the enzyme capping is 8, and increasing the substrate concentration even further will not increase the rate of reaction. So at that time, substrate concentration is no longer a limiting factor. While I increase the enzyme concentration, I will increase the rate of reaction, meaning the enzyme concentration is now a limiting factor. As all of you have learned, when the substrate concentration is a limiting factor, increasing the substrate concentration increasing the rate of reaction. When I increase the marker from 3 to 6 and 6 to 9, the rate of reaction actually increase. However, it comes to a point whereby when I increase the number of marker, the rate of reaction will still be the same. So when the substrate concentration is no longer a limiting factor, increasing the substrate does not increase the rate of reaction. As for enzyme concentration, with increased enzyme concentration, the rate of reaction increases further when the enzyme concentration is a limiting factor. When the enzyme concentration is not a limiting factor, increasing the concentration of enzyme will not increase the rate of reaction. This is because all the substrate molecules are already bonded to the active site of the enzyme molecules. So to sum it all up, when the substrate concentration increases, the rate of reaction will increase until the substrate concentration is no longer a limiting factor. To allow the rate of reaction to become faster, we can increase the limiting factors, such as temperature. We can adjust it to the optimum temperature, or the pH, we can change it to the optimum pH, or we can just increase the enzyme concentration, as enzyme concentration was a limiting factor. The same thing will apply for enzyme concentration. With a low level of substrate concentration, the enzyme concentration will soon become a limiting factor. And by increasing the substrate concentration, we can increase the rate of reaction even further, as it was a limiting factor. Lastly, let us talk about naming of enzyme, because it will be good that you can recognize a word and think that, oh, it is an enzyme. So hydrolase are enzymes that add in water. They are involved in hydrolytic reactions. So you can see one on the right. So in this case, when we add water to sucrose, the enzyme will disrupt the bond. Then you will get glucose as well as fructose. So other digestive enzymes are also hydrolase. For example, amylase will digest starch to maltose. Maltase digests maltose. Protease are those that digest proteins, while lipase are those that digest fats and lipids. So the name itself is kind of related to the substrate. So most enzymes are named after their substrate, and most names of the enzyme commonly end with the word S, A-S-E, not A-R-S-E. However, you will also encounter some enzymes in the next chapter that end with sin, S-I-N. For example, trypsin and pepsin. So what are the functions of those enzymes? You will learn those in the next chapter on the nutrition in human.